Hello everyone, so for today's video we will be discussing the polynomials. As we all know, polynomials are the fundamental in the study of mathematics. In fact, most mathematical expressions are formed out of polynomials. So now let's start with discussing the algebraic expressions. Algebraic expressions has two parts. So we have the constant and the variable. Constant are said to be the symbol whose values does not change. So basically, constant is referred as the numbers. So for example, we have 28, 5, 3, 16, and other numbers in mathematics. Those are what we call the constants. We also have what we call the variable, which is a symbol that takes on different values. The most commonly used variables in mathematics are x, y, z, t, and other variables. Now, that being said, algebraic expression is a variable, or a combination of constants and variables connected by fundamental operations. When you said fundamental operations, these are the addition, the subtraction, multiplication, and division. So for example, we have here the algebraic expression of 3x y cubed minus 2/3 x to the fourth. So this is an example of an algebraic expression. As you can see, it already has the combination of a constant and a variable, and as well as an exponent. So that is what we called the algebraic expressions. So now we will be discussing how to evaluate an algebraic expression. So for example, we have here the first example: evaluate 2ab minus 4c, for a is equal to 2, b is equal to -1, and c is equal to 3. So basically, in evaluating our algebraic expression, we just have to substitute the values of our variable to the expression. So that being said, we have 2 times the value of a, which is 2, multiplied by the value of b, which is -1, minus 4, and the value of our c, which is 3. So we already substitute the values of our variable. Now, performing the operations, as we know from PEMDAS, or as we know from the PEMDAS rule, we need to perform first the operations inside the parentheses. That being said, 2 times -1 is -2, multiplied by 2, so we have -4, minus or subtracted by 4 times 3, that is equivalent to 12. So if you get the value of this one, as we know, -4 minus 12, that is equivalent to -16. So this is now the final answer of our algebraic expression. So moving on with another example, we have here evaluate x squared minus 5xy plus y squared all over 4x squared plus y cubed. For x is equal to -3 and y is equal to 2. So basically just the same process with the previous example. We just have to substitute the values of our variable, which are x is equal to -3 and y is equal to 2. So from here, x squared, x is equal to -3, so we have -3 raised to squared, minus 5, and then the x, which is -3, times y, which is equal to 2, plus y squared, which is 2 raised to 2, all over our denominator, which is 4 times x squared, that is -3 squared, plus y cubed. Y is equal to 2, so we have y cubed. Now, if we solve this one individually, find the value, simplify this one. -3 squared, that is -3 times -3. So we have +9, minus -3 times 2, we have -6, times 5, that is -6 times 5, that is -30. And since this is negative, so we will have +30. 2 raised to 2, that is equivalent to 4, all over the denominator. -3 squared, that is equivalent to 9, and 9 times 4 is equivalent to 36. Now, the same process here, 2 cubed, or 2 times 2 times 2, that is equivalent to 8. Now, if we add this one, if we add the numerator and the denominator, we have 43 for the numerator and 44 for the denominator. So this is now our final answer. So moving on, we will be discussing the index laws or laws of exponents. So I have here the list of laws of exponents. So as you can see, we have the nth power of a, in which a variable or a constant is raised to an n number, meaning to say if how many is the value of our n, how much is the value of our n is the times that we will be multiplying our variable or our constant by itself. So let's say this is n is equal to 3, meaning to say we will also be multiplying our a 3 times. And we also have the product of powers, a raised to m times a raised to n. Given the same base, if our expression has the same base, meaning to say you just have to add the exponents, add their exponents if they have the same base. But if they don't have the same base, then that is a different topic na. So another one is the quotient of powers. So we have a raised to m all over a raised to n. Again, if they have the same base, you can perform the same you can perform the corresponding functions or corresponding operations with their exponents. So given if m is greater than n for this one, if m is greater than n, the quotient is equivalent to copy the base and then subtract the power of the exponent of the numerator by the denominator. So that gives us a raised to m minus n. Then another category is if m and n, if the exponent of our numerator and the exponent of our denominator has the same value, or meaning to say they are equal, so that gives us our exponent is automatically equal to 0. So any number or any variables raised to 0, that is always equivalent to 1. And another one is if the numerator, if the value of the exponent of the numerator is less than the value of the exponent of the denominator, then you have to put it down, or you have to put the answer in the denominator. So that gives us 1 over, copy the base, and then we have n, the denominator, exponent of the denominator, minus the exponent of the numerator. Then we also have the power of a power, a raised to m multiplied by n. So you just have to multiply the power inside and the power outside. So that gives us a raised to m times n. Now we also have the power of a product. For the power of a product, let's say we have a product inside this one, a parenthesis, and it is raised by an exponent. So that gives us, you just have to distribute the exponents to each term or to each variable. So that gives us a raised to n and b raised to n. The same goes with the power of a quotient. If we have a quotient and then it is raised by a power, you just also have to distribute the power to the numerator and to the denominator. So that gives us a raised to n all over b raised to n. So basically that are all of the laws of exponents or index laws that you need to remember. So from the laws of exponents discussed earlier, we'll be answering some examples, each of the laws that we have discussed. So the first law was the nth power of a. So for example, we have express each expression using nth power of a. So for example, we have 4 squared. So that gives us 4 times 4, right? Or let's just say 4 times 4. And that gives us equivalent to 16. So that's just how we solve nth power of a. So let's say for this example, we have, since as you can see, this is not enclosed by parentheses, meaning to say the answer of this one is only the number 4 is squared, not including the negative sign. So that gives us negative 4 times 4. Class, you have to remember that if the base are not enclosed by a parenthesis, you cannot also assume that negative sign is included to be multiplied, because that will just gain a wrong answer. So for this one, negative 4 times 4, that is negative 16. Alright? Now, the last example is, for this one, as you can see, negative 4 is already enclosed by a parenthesis, meaning to say we need also to multiply including the negative sign. So negative 4 times negative 4, as we know, that is negative 4 times negative 4, that is equal to negative times negative is positive. So that is positive 16. So that is how we evaluate or how we answer nth power of a. Now we'll move on with the next law of exponent, which is the product of powers. So by the product of powers, as we know, as discussed earlier as well, if they has the same base, you just have to add the exponent. So that gives us 3 raised to 3 plus 4. So that gives us 3 raised to 7. And as we know, 3 raised to 7 is equivalent to 2187. So we have here another example, a raised to 6, b raised to 4 times a cubed, b squared. So as we know, we cannot multiply this one, we cannot add the exponents of this one because they has different base. So meaning to say, since a raised to 6 has the same base with this one, you can perform the operation of this one and as well as for this one. So a raised to 6 times a cubed, that is a 6 plus 3 times b raised to 4 plus 2. So that gives us a raised to 9 times b raised to 6. So this is now our final answer as well as this one. Since there's no given value for a and b, so then we cannot uh, we cannot substitute any numbers to our variable. So that gives us the answer is still an expression, a variable raised with an exponent. So now let's move on to another law of exponent, which is the quotient of powers. For the quotient of powers, as we all know, as discussed earlier, you just have to check the exponents of the numerator and the denominator. So for this one, the exponent is 4n, and for the denominator, the exponent is 2n. So meaning to say, 4n is greater than 2n, meaning to say y is raised to 4n minus 2n, since the numerator's value has a bigger value than the denominator. So that gives us y raised to 2n, because 4n minus 2n, that is equivalent to 2n. Now moving on to another example, we have 5w cubed y raised to 5. and all over 5w cubed y raised to 5. So as you can see, they has the same base. There's no difference between the base of the numerator and the base of the denominator. And they has the same value, their exponents has the same value, meaning to say this is equivalent to 5w cubed y raised to 0. Now, as we know, any variable or any number raised to 0, that is equivalent to 1. So that gives us the answer 1. Now, let's also discuss another law of exponent, which is power of a power. Now, for the power of a power, given this one, m cubed multiplied by an exponent squared. So again, you just have to multiply the exponent. So that gives us m 3 times 2. So that gives us m raised to 6. For another example, we have negative x squared multiplied by cube. So as we know, negative x squared, this is equivalent to negative x squared, and then negative x squared, and then negative x squared, right? Because this is raised to cube. So meaning to say, negative x squared times negative x squared, as we know, they has the same base, that is equal to um, positive x raised to the fourth, and then multiplied again with another negative x squared. So that gives us, this is now equivalent to positive, that was positive x raised to the fourth multiplied by negative x squared, meaning to say that is equivalent to negative x, and then 4 plus 2, that is positive 6. So again, rewriting this one, to avoid confusion, this is equivalent to positive x to the fourth, right? Because negative x times negative x is positive. 2 plus 2, that is 4. Now, if you multiply this one by negative x squared, which is this one, positive x multiplied by negative x, that is negative x, right? 4 plus 2, that is 6. So that gives us the answer, negative x raised to 6. Right now, we'll move on to another law of exponent, which is the power of a product. So we have here simplify using laws of exponents. Now, for this one again, since it has already two terms inside, meaning to say this is equivalent to 2 raised to 5 and x raised to 0 times 5, correct? Now, 2 raised to 5, as we all know, that is equivalent to 32. And then we have x, 0 times 5, that is also equal to 0, right? So, meaning to say x raised to 0, that is equivalent to 1. So, we have 32 times 1. That gives us the answer of 32. So, this is now our final answer. For another example, we have here the same process. You just also have to distribute the exponents to each term inside the parentheses. So we have negative 4 cube x 2 times 3. Then we have y 3 times 3, right? So that gives us the answer of negative 4 cube, that is equivalent to negative 64. Then x raised to 2 times 3, that is equivalent to 6. And y raised to 3 times 3, that is equivalent to 9. So this is now our final answer. Now moving on to the last law of exponent, we have power of a quotient. So the same as discussed earlier, you also have to distribute the power or the exponent. So that gives us 3 squared all over 2 squared. Now, if you simplify that one, that gives us 3 squared is equivalent to 9, and 2 squared that is equivalent to 4. So this is now our final answer. Now, for the another example, we have negative 4 raised to negative 4 raised to 3 and x raised to 3 times 3 all over 3 cubed y squared times 3. So that gives us negative 4 cubed, that is equivalent to 64. That is equivalent to negative 64. And x raised to 3 times 3, that is 9. All over 3 cubed, that is equivalent to 27. And we have y is equal to 2 raised to 2 times 3, that is equivalent to 6. But as you can see, they has different variables, so meaning to say we cannot perform any other simplification for this one. So that gives us the final answer, negative 64, x raised to 9, and 27, y raised to 6. But if you can still simplify this one, if there you can still simplify the constant, you can. There's no limit to that. So that's it for this video. I hope you learned something from this video, and I'll see you on the next video. Thank you.